I am happy to name this ship the Queen Mary.
My name is Will Kane. I act as captain of the Queen Mary on a daily basis. On behalf of the rest of my crew and staff, I'd like to take this opportunity to welcome you all aboard. We're about to enter the after engine room. This engine room contained 2 turbine units. These engines controlled the 2 inboard propellers. The outboard propellers were controlled by a nearly identical plant forward of here. All of these men looked after the ship's powertrain, which was comprised of 2 engine rooms, 2 turbo generator rooms, and 5 boiler rooms that housed a total of 27 boilers. Here we are at the starting platform, or control panel. This was essentially the engine room's nerve center, and everything was controlled and operated from right here. The men down here in the engine room had to stay in constant communication with the men up at the bridge. They were steering the course of the ship. The men down here were providing the power. The bridge would relay its orders through these telegraphs, which were connected to a matching set up top. If full steam ahead were rung up there, it would register down here with a ring. The green arrow would point to the instruction, and then the engineers would then ring their telegraphs in response. This told the bridge that they received the order and were getting to work. Adjusting the speed meant adjusting the amount of steam going into the turbines. Full steam ahead meant that the valves were opened all the way, which let the maximum amount of steam into the engines. These other wheels controlled the reversing steam and were used to either back up or suddenly stop the ship in an emergency. This center telegraph, however, relayed messages to boiler room 3 and 5. There would have been a similar one in the forward engine room that connected to boiler rooms 2 and 4 as well. Unlike the engine telegraphs, however, the boiler rooms couldn't ring a response on their end. They just received instructions and made it happen as quickly as possible. To make things a bit easier for the men, these phones were designed to filter out excess noise. Called loudophones, they allowed the speaker to have a conversation at normal tones. One of the questions we often get is how many men work down here. It seems hard to believe, but this whole room could be run by 5 men. And each one had to know what every gauge and dial stood for. They were on 4-hour shifts only because of the heat. They actually had to wear specially designed shoes or boots that had a sole on them that was a 1/2 inch thick made of wood, because eventually anything else probably would have melted. A total of 84 officers were responsible for maintaining the Queen Mary's systems, starting from the chief engineer and working down to the staff chief engineer, the chief electrical officer, and several other junior ranks as well. An army of greasers, firemen, and trimmers worked beneath them. The boilers produced steam that was superheated to 700 degrees Fahrenheit, which is what actually powered the ship's engines. Each boiler produced 80,000 pounds of steam an hour, and all 24 main boilers produced 1,920,000 pounds per hour. That's 16 tons of steam a minute. Exhausted steam was sent to the main condensers so it could be turned back into water, which was accomplished by drawing in cool seawater from the main circulating pumps. This in turn caused the steam to condense, and the resulting water was recirculated back to the boilers. The pump's openings, known as sea chest, were found at the bottom of the ship, and they worked well when the tide was high or the ship was sailing in open water. They didn't work quite as well at low tide. Here we see 2 quadruple expansion engines. Each engine was actually a unit made up of 4 different steam turbines. The steam is delivered via these pipes from the boiler rooms, in this case boiler rooms 3 and 5. It's then sent into the first turbine, called the high-pressure ahead turbine, which took the steam at a very high pressure. It then lost a little bit of its initial power From there, it was sent to the first intermediate pressure turbine and then the second intermediate pressure turbine. The ship's main gears were housed in these cast iron cases to either side of me. Power would be transferred from the turbines to the propeller shafts via the gears, which you can see within the portside unit. Inside each one were 257,000 individually hand-fitted blades. When that steam was piped back into the engine room and that steam hit those 257,000 blades, they all started turning at the same time. Finally, the steam, now at a much lower pressure, was sent into the low-pressure turbine. From there, it was sent to the main condensers where it was recycled and reused. To keep everything properly lubricated, each engine and gear combination needed 5,000 gallons of oil, 20,000 gallons for all 4 sets. Every bit of that oil was recirculated and reused. The engineers didn't waste a thing if they couldn't help it. Over here we have one of the ship's main turning gears. It's a total of 14 feet in diameter and would have made 1 full turn every 9.8 minutes. There would have been a cover over it, however. It wasn't exposed like it is today. This gear was only engaged whenever the turbines were being warmed up or cooled down, which prevented internal distortion. You probably noticed the damage to the gear teeth. Right next to it is the main thrust bearing, which transferred power from the shaft to the ship. This, in turn, created a counterforce that pushed directly back against the screw, which radiated through the shafts. The thrust bearing absorbed that force and transmitted it to the ship, which kept the shafts virtually in place. They did move 1/60,000th of an inch, but this was necessary because the ship's hull was constantly flexing. They had to move accordingly, otherwise there could be serious issue with vibrations. The area that we've been walking through is the starboard tunnel, which is also called Shaft Alley. Here you can see 2 of the propeller shafts that connected to the ship's turbines. The one that's closest to us, if you remember, was powered by one of the engines we just passed. These shafts are 30 inches in diameter and extend some 230 feet in length. Now, believe it or not, this section of the ship was much cooler and quieter than you might think. It was away from all the noise and heat of the engines, and the propeller shafts ran virtually silent. Out here, however, one engineer noted that the tunnels could be rather lonely places to work. Behind you, you'll notice one of the Queen Mary's watertight doors. There were 38 of these doors altogether, 34 closed horizontally like this one, while 4 shut vertically. All of them, however, would close in about 40 seconds with 700 pounds per square inch of hydraulic pressure. We know of one crew member that was unfortunately crushed to death here in July of 1966. The circumstances surrounding his death remain a mystery. This whole area is the aft steering gear, which controlled the ship's massive 150-ton rudder, one of the largest ever installed on a ship. The tiller, which is a lever connected to the rudder post, would be swung by 4 hydraulic cylinders. They were designed to work in pairs. That way, 2 would continue working if the others failed. If all of the cylinders failed, however, then the tiller could be manually operated from the auxiliary controls down here. Instructions would be relayed from the bridge, and whoever was steering responded accordingly. As we head out, you'll see one of the wrenches used to remove the propellers during the Queen Mary's annual overhaul in Southampton. Below us is one of the Queen Mary's massive propellers. There were 4 of them altogether, and this is the last one attached to the ship. The other 3 were removed when the ship arrived in Long Beach and put on display throughout Southern California. They were made of manganese bronze, and at the time of the ship's construction, the heaviest ever cast. When she was first set sail in 1936, the propellers each weighed 35 tons. They were 20 feet in diameter. These were replaced later in the Queen Mary's career, however, because they actually caused the ship to vibrate uncomfortably. The new propellers weighed 32 tons and were 18.5 feet in diameter, which is what you see today. At full steam, these propellers would turn 3 times a second. That's 180 revolutions per minute. Each turn theoretically pushed the ship forward 18.5 feet. There would often be more than 1 million revolutions by the end of a 5-day crossing, which should give you an idea as to how hard these machines worked. It was this raw power that made the Queen Mary the fastest ship in the world for 14 years, from 1938 to 1952 when the SS United States entered service. This is the reason she was our #1 stronghold against the enemy during World War II. Adolf Hitler, as well as the Emperor of Japan, put up a $250,000 bounty, plus the Iron Cross with oak leaves, to any submarine captain who would sink the Queen Mary just to get her out of the way. Sir Winston Churchill said that we were able to win World War II in the amount of time that we did because of the performance of this ship. That's a pretty powerful statement to be able to make. Once again, on behalf of my staff and crew, I want to thank you for coming aboard and taking this tour. I hope you enjoyed it and that you learned a little something about this international historic treasure, the Queen Mary.